The NEOSUCCESS Project is a Horizon 2020 program and comprises a first-of-a-kind technology solution which is connected to the growing demand for bio-based products and energy with low carbon footprint. Biogas and sugar-rich waste streams are utilized through a fermentation process with Actinobacillus succinogenes 130Z to simultaneously produce two high-value products, biomethane and biosuccinic acid. These products have received increased attention and can be used towards future industrial biorefining applications. 4 partners are involved in the project, 2 universities and 2 engineering companies. The constructed industrial unit is located in Spain, just outside of Valencia. The downstream process is consisted of various steps and equipment laid out in a series as it is depicted in the flow diagram. Specifically, the first step is centrifugation to remove the biomass and solids from the fermentation broth, followed by ultrafiltration with 2 meshes to remove any remaining solids and big compounds. Afterwards, the process of nanofiltration takes place to eliminate any remaining sugars and byproducts in the broth. Finally, a step of spray drying is implemented as a method of forming the final product, which is dry succinic acid powder. The filtrated liquid from the previous steps is sprayed through a nozzle into a drying chamber where the liquid and any remaining byproducts are evaporated. The separated high-purity succinic acid can be further used as a platform chemical in various industrial applications. Fermentation broth that was previously produced in the upstream process is used for the downstream. Initially it is placed in a high-volume storage tank, and after each downstream step the liquid is stored in smaller tanks until it is pumped for the next consecutive step.
Hello, here we are in the next steps of the process regarding the purification of the biosuccinic acid so that we can use it as a valuable platform chemical for further use in the industry. Specifically here we have a series of downstream steps, and we are starting off with a centrifuge to remove the remaining solids that came from the fermentation, biomass and other residues, and then we pass to an ultrafiltration step with a double-step process with 2 meshes, 1 and 5 microns, where the remaining solids would be completely eliminated before going to the nanofiltration unit. And then we go to the nanofiltration unit, where there we can actually effectively separate the succinic acid from the rest of the components inside the broth, and then we can actually pass forward to the spray drying, which will be the final step to create the powder of the succinic acid. Here we are at the centrifugal separator, where the broth that comes after the fermentation, here we can remove all the solids. And this is the first step of the downstream process. So here we are in the second step of the downstream process, and specifically on the ultrafiltration unit. It's consisted of 2 steps, 2 meshes of 5 and 1 micron, to eliminate any remaining solids and residues that were left. And during filtration we can actually take samples to analyze the composition to see what is rejected. So after the ultrafiltration, what comes through, it actually goes eventually in a storage tank before the nanofiltration, where we check the pH, and if need be, we adjust it and lower it below 4 or around 4 to actually we can initiate an effective nanofiltration. Pump is going to pump through the unit, and here we will set our parameters, the permit, the rejection and the recirculation values, and we will adjust according to the pressure that we want to achieve. So after adjusting the parameters, during the process, we can actually take samples for lab analysis through these pathways for the impairment and the rejection. After that, it leads to another storage tank, where it will be the initial tank that goes into the final step of the downstream process, the spray drying. Here we are at the last step of the downstream process, and specifically the spray dryer. The permit of the nanofiltration unit will be pumped through from the storage tank inside the machine, and afterwards it will start working in the specific conditions. We can set and tweak the parameters in the controller and set the temperature and the frequencies that we would like for it to work. The powder will go through this system, and eventually we will retrieve it through this vessel. And this will be the final step, and we will acquire the powder of the succinic acid. After finishing the whole downstream, we would analyze the powder from the succinic acid to see its purity and to calculate the mass balances for the final recovery values.